For the first part here, what we're going to look at with this log, we're going to try to use the base property, which says that log base b of b to the x equals x. So in order to do that, we have this base 4, so we need to rewrite this cube root of 16. Well, we can change this to log base 4 of 16. We can write as 4 squared, and the cube root is the 1/3 power. So this becomes log base 4 of 4. When you have one base, you multiply, so the exponent becomes 2/3. So then that's your answer, 2/3. For the next problem, we have the plus sign. We have the log base 5 of both of these. So we are able to multiply these two right away. But what I'm going to do first is I'm going to use this same thing. I'm going to use the base property first. And the reason why is because it's easier to simplify the problem if I start with this versus starting with the product property. So what happens is we get log base 5 of 5 squared plus log base 5 of 5 cubed. And by using this base property, this becomes 2, this becomes 3, and then it's easy to see that the answer is 5. Okay. For this one, I have log base 6 of 42 and log base 6 of 7. And I have a minus in between, so I can use the quotient property. Now, first I look to see if I can use the base property, but with this one, 42 and 7 will not end up with a base of 6. So what I'm going to do is I'm going to go ahead and start with the product property, or the quotient property this time. So I have log base 6. I'm going to write one log, but instead of subtracting, I'm going to do the quotient. So 42 goes on top because it's positive coefficient. This has a negative coefficient, so the 7 goes on the bottom. And then we get log base 6 of 6, and then that equals just 1. When I look at this one, I'm like, all right, well, they have different bases. I have a number, so there's not really much for me to work with here. So the best approach is to use the change of base. So the change of base, we're going to take the log of the number divided by the log of the base. You can pick log, you can pick natural log, you can pick log of any base. I'm just going to go ahead and do the common log, which is log base 10. So I have the log of the number, which is 5, over the log of the base, which is 7, times the log of the number is 49, so I'm doing change of base here, over the log of 5. So this is nice because we're multiplying. These are products, so I can cancel out the log of 5s. And log of 49 is the same as the log of 7 squared. Okay, now I cannot cancel anything out here because I have the log of 7 squared divided by the log, so there's no canceling. What I can do here is I can use the power rule. Okay, so the power rule says if you have like log base b of x to the a, that this is equal to, you bring the exponent in front, so that's log base b of x. So that's what I'm going to do here. So I'm going to bring the 2 in front, so I have 2 log 7 over log 7, and now you'll notice I can cancel out the log 7s. Okay, you can only cancel the logs out this way if they're the exact same thing. So this becomes a 2 right here. Okay, for the next problem, we do have a property that says if you have a base to a log with the same base of some number, okay, then that is going to equal whatever that number is, x. All right, so we're going to be using this property. So over here, we have e raised to this combination of numbers here. The thing is, if we have 2 logs with the minus sign, we can use the quotient property. So this is really the natural log of 6 over 30. And since the base matches log base e here, so it's e raised to the log base e, so this is e and this is e, then I know that whatever I'm taking the log of has to be the answer. So it's just going to equal 6 over 30, but 6 over 30 reduces. So you need to make sure to reduce, and this is going to be 1